In this lecture, we will solve another type of numerical on determination of main dimensions of a synchronous machine. And the numerical is for a 2500 kVA 3.3 kV 32 pole 50 Hz generator, find the suitable values of core diameter, core length, peripheral speed. The specific magnetic and electric loading may be taken as 0.68 Weber per meter square and 30,000 ampere conductor per meter respectively. The ratio of the pole arc to pole pitch for a circular pole is to be used is 0.65. Now, if you read this example, then in this example it is given that kVA is equals to 2500, frequency is 50 Hz, number of poles are 32. So at 50 Hz frequency and 32 number of poles, if we calculate the NS by using the NS is equals to 120 F by P, we will get the NS is equals to 187.5 RPM. The specific magnetic loading is 0.68, that is BAV. Specific electric loading is 30,000, that is AC. Along with that, the ratio of pole arc to pole pitch is given. Pole arc to pole pitch. So the ratio of the pole arc to pole pitch is equals to 0.65. And we need to calculate the three quantities, that is the core diameter D, core length L, and peripheral speed is the V. So let me start this example with the output equation. As we know that the output equation is D square L into is equals to kVA divided by CO into NS, where the CO is 1.11 into kW into BAV into AC into pi square into 10 to the power minus 3. As the winding factor is not given in the example, let me assume the full pitched winding, for which the kW is 0.955. So with this, let me calculate the CO as 1.11 into 0.955, that is kW, 0.68 that is the BAV, 30,000 as AC, pi square into 10 to the power minus 3, and after the calculations we will get here the 213.43. As the kVA is directly given in the example and which is 2500, so the only unknown is now the NS. As the capital NS is given 187.5 RPM, then the small ns becomes 187.5 divided by 60, and that is equals to 3.125 RPS. So after inserting these values in the D square L product, the equation becomes 2500, that is kVA rating, divided by 213.43, that is CO, into 3.125, that is NS, then we get 3.748 meter cube. Now the next step is to separate the D and L from the product D square L, and it is given a constraint for separating the main dimensions as the pole arc to the pole pitch ratio is 0.65, where it is also given the pole is a circular pole. And in the previous lecture I have already told that for a circular or round pole, if we assume the square pole face, then the L is equals to pole arc. So if you take the L is equals to pole arc in this equation, then the pole arc can be replaced by the L, and pole pitch is equals to tau. So in simply the L by tau ratio we can assume as 0.65. L by tau is equals to 0.65, means L is equals to 0.65 into tau. As we know that the pole pitch tau is equals to pi d into p, so 0.65 into pi d into p, and if we calculate by inserting the p is equals to 32, we get the L is equals to 0.0638 d. Now this value of the L we will put in the equation 1. So the equation 1 becomes 0.0638 d cube is equals to 3.748, and after calculating this we will get the d is equals to 3.9 meter, and this value of the d we will put in the equation number 2, which is L is equals to 0.0638 d. Then the value of L becomes 0.25 meter. Now the calculated value of the d and L becomes, here the d is equals to 0.39 meter and L is equals to 0.25 meter. So along with the d and L, it is asked to calculate the peripheral speed, and the peripheral speed is equals to pi d into n. So if we put here the d is equals to 3.9 and n is equals to 3.125, then the value of the peripheral speed becomes 38 meter per second. And for the synchronous machine, I already discussed in the previous lecture that the allowable peripheral speed is 50 meter per second. So the calculated peripheral speed is within a range, that is below the 50 meter per second, that is 38 meter per second. So the calculated values of the main dimensions d and L are acceptable. So our final answer becomes that d is equals to 3.9 meter, L is equals to 0.25 meter, and the V is equals to 38 meter per second. So similar type of two examples I have given in the exercise. Example 1 and 2. Solve these two examples as a practice at home. Thanks for watching.